So now we'll pick some of the questions and we will find the corresponding partial derivatives. Like if it involves two variables, we find partial derivatives with respect to f, x and y. Then if it is involving three variables, we find the partial derivative with respect to x, y and z. So see, the concept remains same. Like here, when we are differentiating with respect to x, if you're differentiating with respect to x, consider y as a constant. And then when you are differentiating with respect to y, consider x as a constant. Now you can extend this concept to the function of three variables. Like here, u is a function of x, y and z. So when you are differentiating with respect to x, you have to treat the remaining two variables y and z as constant. Okay. Similarly, if you want to differentiate with respect to y, consider the remaining two variables which are x and z as constant. And then when you differentiate with respect to z, treat the remaining two variables x and y as constant. And then we can easily find the partial derivatives. So let's begin with this term. Now, if we need to find the partial derivative of f with respect to x, so either you represent it as partial f by partial x or you can represent it by fx. Okay, so we differentiate it. Now we are differentiating it with respect to x. So we should consider the other variable which is y as a constant. Now when y is a constant, check what are the terms that you need to differentiate. You need to differentiate x power 2. Here you have the term x power 2 that you need to differentiate. Other things will be same. You are not changing. Okay, so this is now 2 times, what is derivative of x power 2? 2x minus 3. Again x power 2, derivative is 2x. Don't change y, keep it same. Plus. Now what you can see here? Here no x in this term as well as in the last term. So it means it is a constant. So derivative of a constant is 0. So derivative of 5y becomes 0 and derivative of 1 also becomes 0, because we know that derivative, suppose if it is with x, of a constant term is 0. So what we have to do? What we did actually. X square, the derivative is 2x. X square, again the derivative is 2x. Remaining terms we didn't change. And as in the last term, there is no x, we make it 0, and derivative of 1 also as 0. So finally we got it as, we got the first derivative fx as 4x minus 3 times 2, 6xy. This is your fx. Okay. Similarly, if I want to find fy, so it means the partial derivative of f with respect to y. So here now we are differentiating with x, with y, so we consider x as a constant. Now in this case, when we are differentiating, we are looking for the function of y that we have to differentiate. So here you can see this is your y term and this is your y term. In other places you don't have y. So what it will become? Now in the first term there is no y. So derivative with respect to y of a constant is also 0, because x is a constant. So it becomes 0. Minus 3 is a constant, x square is a constant, derivative of y is 1, plus 5 is a constant, keep it same, derivative of y is 1, plus 0, because 1, again there is no constant. So what we did, in place of y we wrote its definition, derivatives. Here also the derivative. Here, because in these two terms we were having the function of y, so we differentiated it here, whereas in first and last term there is no y term, so we directly put it as 0. So what we got here, minus 3x square plus 5 is the derivative with respect to y. So these are first order derivatives. These are first order derivatives. These are derivatives of first order. Now similarly, you can find the derivative of second and higher order as well. Okay, like how we were doing it for the function of one variable. So now, just recall it, when you have y as a function of one variable, so what we were doing, suppose say y is equal to say x power 7. So you find the first derivative y dash by differentiating this 7x power 6. Now if you want the second derivative, what we will do? We differentiate the first derivative again. So it means 7 times 6x power 5. This is how we do it, right? So same concept will be used here. Now when we want to find the second order derivative, now this is fx. Now this is first order derivative. Now the thing is that we can differentiate it with respect to x again. So we represent the derivative as f x x, because now 2 times x, we are differentiating it with respect to x twice. So now instead of using the original function, we will make use of this function. So it means we have to differentiate this term with respect to x again. So now tell me, what will be the derivative? 4 times x. So okay, let me just write. It means we are differentiating with respect to x this term, which is 4x minus 6xy. So when we are differentiating, we are considering y as a constant. So derivative of 4x gives you 4 minus derivative of 6xy. What it will give you? 6 is same, derivative of x is 1 and y same. So how do we got here 4? Because it is 1. So we can write 4 minus 6y. So this is nothing but your second partial derivative with respect to x. Similarly, if we have fy, we can differentiate it again. Say, suppose now we talk about the with y. So what it will be? F, first derivative is already with y, then we differentiate it again with y. So this will be partial derivative with respect to y. Now instead of original function, we will be making use of this term, minus 3x square plus 5. Now as we are differentiating with y, we consider x as constant. So here what you see, in first term you have only x, and second term you have a constant. So both terms are constants, so you will get 0 plus 0, which is 0. So you get second partial derivative with respect to y as 0. Now here, as f is a function of x and y, both two variables x and y, it is possible to find the second partial derivative with respect to other variable as well. Now this function fx, we can differentiate it with respect to y as well. So in this case, what we will do, we will write it as f x y. So means now the representation varies from authors to authors. Some represent it as xy, some represent it as yx. So here we can write it as derivative with respect to y of the term fx. Okay, this is what is mean. Here this was the term fx. So it was derivative with respect to x of fx. Now it is possible to differentiate it with respect to y as well. So now what will happen? If you find this derivative with respect to y of fx is 4x minus 6xy. So now in this case, as we are differentiating with respect to y, we consider x as a constant. So it means we just differentiate this term y, and since other term is constant, it will become 0. So this gives you, for 4x it is 0 minus 6x, the derivative of y is 1. So here we can say that f xy is minus of 6x. This is how we define the mixed order second partial derivative. Similarly, it is possible to differentiate it with respect to x as well. So in this case, we represent it by f y x. So we can represent it as derivative with respect to x of f y. It was fy here. Derivative with respect to y of fy. So this is nothing but partial derivative with respect to x of fy, which is minus 3x square plus 5. Now see, we are differentiating here with respect to x. So we have to differentiate the function of x, and if there is some variable y, we have to consider it as a constant. So what is here? This will give you derivative of this minus 3 times x square is 2x, and derivative of 5 0. So this gives you minus 6x. So what you can find? Derivative of mixed partial derivative of f with x and y is minus 6x. Okay. So what we observe, that the mixed partial derivative, that if you differentiate function first with x and then with y, or you differentiate function first with y and then with x, you are getting the same values. Okay, so here, so what you can see, we have two first order partial derivative and we have 4 partial derivatives of second order. So this is fxx, fxy, fyy, and fyx. Okay. So what we have seen, that when we have a function of two variables, we are finding the first order derivatives as well as second order partial derivatives. So this is how the tree will work out. So you have u, you can differentiate it with respect to x, you denote it by ux, or you can differentiate it with respect to y, that you denote it by uy. So this is the partial derivative of first order. Okay, then when you have ux, you can differentiate it again with x, which gives you uxx, or you can differentiate it with y, which gives you uxy. Similarly, when you have uy, you can differentiate it with respect to x, which gives you uyx, and then you can differentiate it with respect to y, which gives you uyy. So this gives us the 4 partial derivatives of second order. So now let's follow this and work on this. Again, now it is e power x square plus y square. So it's clear that we have to make use of chain rule to find it. So let's start. Ux, it means y is considered constant. So whenever we work with chain rule, how do we do that? So first we apply the basic rule. So basic rule of derivative. We know that the derivative of e power x is same. So it will be same e power x square plus y square times the derivative with respect to x of the power x square plus y square. So this gives you e power x square plus y square times the derivative of this term with respect to x is 2x, because y is constant, so its derivative becomes 0. So this is the value of ux. Similarly, when we want to find uy, we consider x as a constant. So again, by using the chain rule, exponential function, the derivative remains same, e power x is e power x. Now multiply by the bracket, so it is the derivative of this term with respect to y. So this gives you e power x square plus y square times the derivative. Now x is constant, so its derivative is 0, and derivative of y square is 2y. This is nothing but u of y. Okay, so these are two first order partial derivatives. Now let's talk about second order. These are first order. Now let's go to the second order partial derivatives. So let's begin with uxx. So when we are doing this, it means we are differentiating with respect to x, ux, right? And the value of ux is this term. So it is having the partial derivative with respect to x of e power x square plus y square times 2x. Now if you remember, whenever we have to find derivative of product of two functions, we cannot do it directly. Instead, we have to make use of product rule. So here you can see that you are differentiating with x, and you have a function of x here as well as here. So you have to make use of product rule. What the product rule says? Product rule says that whenever you are finding derivative of two function, product of two function, which you also denote it as uv dash, it is derivative of first function times second function plus first function times the derivative of second function. Okay, so we'll use the same concept here. So let's consider this as u and this as v. Don't mix with this u here. Okay, so let's write it. So what we need the derivative of u and v with respect to x. So if u is e power x square plus y square and v is 2x, now we want their derivative with x. So how do we find it? Again, we have to make use of chain rule. Okay, so it gives you e power x square plus y square times the derivative of the bracket. So this gives you e power x square plus y square times 2x. Similarly, if you want to find derivative of v with respect to x, this will be 2. So now just simply put all these values in this formulas. We will get our result. So this will give you u dash, which is this term, e power x square plus y square times 2x multiplied by v. V is this 2x plus u, which is e power x square plus y square times vx, which is 2. Now just simplify the term. We can multiply 2x with 2x. It gives you 4x power 2, and you can write it in the front. 4x power 2 e power x square plus y square plus, bring the number in front, So it is 2 e power x square plus y square. This is your uxx. So let's begin with the other partial derivatives. So ux we already differentiated with respect to x and we got uxx. Now similarly, when we have to find uxy, so it means we differentiate with respect to y the term ux, which will be the derivative with respect to y of ux is e power x square plus y square times 2x. Now here you can see that you don't have to use product rule unlike the previous term uxx. Here we use product rule because we are differentiating with respect to x and we are having the term of x here in both the terms which are under multiplication. So we make use of product rule. But here this is not the case. Here you are differentiating with respect to y and you have the function of y only in the first term. The second term can be considered as a constant. So we just differentiate this one. So when you differentiate this with respect to y, what it will become? Again using chain rule. E power x square plus y square times the derivative of x square plus y square with respect to y is 2y and this 2x copy same. Okay, so I hope it's clear how do we get 2y. See, it's like we are multiplying and this is comes as the derivative with respect to y of x square plus y square. So derivative of x will be 0 with respect to y and for y square it will be 2y. So now we can write the term as uxy equal to, now simplify it. We can multiply it together. 2 times 2 gives you 4 x and y and we bring these terms to the front. So 4xy e power x square plus y square. So this is uxy. So we finish with the second order partial derivative when by using ux. Now we work with uy. So let us first find uyx. uyx. So what it will be? Derivative with respect to x of uy. So let's see what it gives you. Derivative with respect to x of uy. uy is this term. E power x square plus y square times 2y. Now see, what is the condition here? Here you are differentiating with respect to x. So when we are differentiating with respect to x, we consider y as a constant. So when you are differentiating with x, you have x only here. So it means you have to differentiate only this term, the first term. Okay, so again you don't have to make use of product rule. Just the chain rule will work. So this will give you e power x square plus y square times the derivative of x square plus y square with respect to x is 2x times 2y. So this gives us uyx as, if we multiply them together, 4xy e power x square plus y square. So this is how we got the partial derivative. Now let's find uyy. So it is the partial derivative of with respect to y of fy, which is partial by partial y of uy. Sorry, not fy, it's uy, and uy is this term, e power x square plus y square times 2y. Now here Here what we can see, it is product of two terms and both the terms contains y. So we have to make use of product rule here like we did in this case. So working with it, let's assume this as u, this as v. So u is e power x square plus y square, v is 2y. Now we are differentiating with respect to y. So uy is, when you differentiate, is e power x square plus y square times 2y. See, in this specific question you can see that this u and the original function is same. That's the reason you are getting uy same. Okay, but this is not always the same situation. This is what I am saying. Your question is same here. Okay, then vy is 2. Now substitute this thing in the product rule. So product rule in this case will become uy times v plus u times vy plus u times vy, like we did here. Here what we did, in place of u dash we use say ux times v plus u times vx. This is what we followed in the previous one. So let's write it down. So this will give you uyy as uy, which is this term, e power x square plus y square times 2y times v, which is 2y, plus u, which is here, e power x square plus y square times vy, which is 2. Simplify it, right? 2y times 2y gives you 4y power 2, e power x square plus y square plus 2 times e power x square plus y square. So this is the fourth second order partial derivative. So this is how we can work with. So these two are partial derivatives of first order, and these in the boxes are the partial derivatives of second order. Okay, so this is how we work with the function of two variables. So similarly, when we have a function of three variables, let's see how to find the partial derivative. So if we say, if we need to find partial derivative with respect to x, we have to treat other two variables as a constant. So y and z are constant. So we are just differentiating the term which is with x. As this is just one term, we differentiate the cosine term. So derivative of cosine 3x is sine 3x times 3, again by using the chain rule, and we keep the remaining terms same, sine 2y e power z. So you get the derivative as 3 sine of 3x sine of 2y e power z. This is the partial derivative with respect to x. Similarly, when you find partial derivative with respect to y, consider x and z as constant. So in this case, the only function that you have to differentiate is this. Okay, so cosine 3x is same. Wait a minute, derivative of cosine is minus sign, so it will be minus here. Okay, now derivative of sine is cosine 2y times 2 e power z. So this gives you 2 cosine of 3x cosine of 2y e power z. Similarly, if you want to differentiate with respect to z, consider x and y as a constant. So now you will be differentiating just e power z. What is derivative of e power z? It is same. Exponential function will be same. So this is what will be the first order partial derivatives with respect to x, y and z.